Ionization energy, it is one of the most important properties of atoms in the periodic table, and it is the amount of energy which is required in removing one electron from a neutral atom, and the neutral atom is in gaseous state. To understand ionization energy better, let me take one example here. This is the atomic structure of magnesium atom, right here, magnesium, and in its outermost shell it has 2 electrons, and these electrons are known as valence electrons. When one valence electron is removed by a certain amount of energy, and the amount of energy which is required in removing this electron is known as ionization energy. And when one electron is removed from this magnesium atom, it carries positive charge. One positive charge shows that it has lost one electron, and when further the second electron of this magnesium atom is removed by ionization energy, it carries +2 charge, and +2 charge shows that it has lost the second electron in its outermost shell. Since there are no electrons left in the outermost shell, that is what it is left with 2 shells only in which electrons are present. But there are various ionization energies of one particular atom based on the number of electrons in it, and so those ionization energies can be labeled as I1, I2, I3, I7, etc. First ionization energy, I1 stands for first ionization energy, and it is the amount of energy which is required in removing one electron. Here one electron is removed from magnesium atom, and the amount of energy which is required, that is known as the first ionization energy. This is the example of first ionization energy. And so I2 represents the second ionization energy, and it is the amount of energy which is required the second electron from that particular atom, and this ionization energy represents the second ionization energy because the second electron is removed by this ionization energy from the magnesium atom, well, and so on. Here in this table, the successive ionization energies of atoms present in third period is shown, and say these ionization energies are given in kJ per mole, kilojoules per mole. As the successive outermost electrons from an atom are removed, their ionization energy of atoms also increases. You can see that their successive ionization energy is given in the increasing orders. Here I2 is greater than I1 and I3 is greater than I2. This is because inner shell electrons are closer to the nucleus, and the nucleus force pulls the inner shell electrons towards the nucleus. As a result, it requires more energy to remove the inner shell electrons. That is why the successive ionization energy is in the increasing orders. But when it comes to remove the innermost shell electrons, these are the electrons which are present very close to the nucleus, and these inner shell electrons are much more closer to the nucleus than the valence electrons. That is why it requires a lot of energy to remove the inner shell electrons, because they are having a strong nuclear force over them, and that's why you can see that inner shell ionization energy of inner shell electrons is very large. Here you can see, if you compare these values are very large. Now let's discuss the trend of ionization energy in the periodic table. This is the periodic table is given, and in this table the arrows show the trend of ionization energy. This arrow shows that ionization energy increases from left to right, and this arrow shows that ionization energy decreases from top to bottom. But the question arises here, why does ionization energy increases from left to right and why does it decrease from top to bottom? This fact can be explained by using this periodic table. In this periodic table you can see that different atoms are displayed with their respective atomic numbers, and when we look at the group from top to bottom, there is an increase in the atomic number of atoms. So there is a sudden increase in the atomic number of atoms. You can see 1, 3, 11, 19, 37, 55 and 87. And as the atomic number of atoms increases, the number of periods also increases. Remember, the number of periods represents the number of cells, and so it means that from top to bottom the number of cells are in an atom also increases, and as the number of cells increases, the atomic size of atoms increases, and when the atomic size of atoms increases from top to bottom, the nuclear charge decreases, and hence therefore ionization energy of the atoms from top to bottom decreases. Well, the question is, what is nuclear charge and why does it decrease from top to bottom? It can be explained by using the atomic structure of atoms. Lithium, let me take two random atoms, lithium and potassium. Lithium is present in second period, it means that it has 2 cells, and potassium is present in fourth period, it means that it has 4 cells. Well, this is these are the atomic structures. This is the atomic structure of lithium and this is the atomic structure of potassium atom. And so you can see that potassium atom is having more cells than the lithium atom. That's why the atomic size of potassium is larger than the lithium atom. You can compare, you can see, visualize these images. Well, and as the atomic size of potassium atom of an atom increases, the distance between outermost electron and nucleus increases. This is the central atom, the central part of the atom, and this central part is known as nucleus. I will mention here nucleus. And so nucleus has protons which have positive charge. That's why nucleus is positively charged, and electrons are having negative charge. That's why these are negatively charged. And so due to this opposite charge, positive and negative, there is a kind of force which is working between nucleus and outermost electron, and this force is known as nuclear force. We can say nuclear charge, and this force attracts or pulls outermost electrons towards the nucleus. And when the distance between outermost cell and the nucleus increases, the nuclear force decreases. As a result, this outermost electron can be removed very easily. I mean to say that this outermost electron can be removed by using small amount of energy. As a result, ionization energy of an atom decreases too. Well, the same fact can be used in explaining why the ionization energy of atoms increases from left to right. Well, when we look at the atomic number from left to right in the second period, you can see that atomic numbers is given 3, 4, 5, 6, 7, 8, 9, 10. The atomic number of atoms increases, but number of cells remains same. It means that the valence electrons in these atoms increases from left to right. And as the valence electrons increases, the nuclear force becomes stronger. It pulls the electrons towards the nucleus more strongly. As a result, the electrons in the outermost cell cannot be removed easily. It requires a lot of energy, and that is why ionization energy of atoms increases from left to right. Well, in overall discussion, we can come to the conclusion that ionization energy depends upon the atomic size of the atoms. Here we have one statement: ionization energy depends upon the atomic size of atoms. It means that when the atomic size of atoms increases, ionization energy decreases, and when the atomic size of atoms decreases, ionization energy of atoms increases. Or in other terms, we can say ionization energy is inversely proportional to atomic size. And one more definition we can use, that we know that nuclear charge, as the nuclear charge increases, the ionization energy also increases. So we can say that ionization energy is directly proportional to nuclear charge and inversely proportional to the atomic size of atoms.